Alright, here we want to find the area of the inner loop of this polar curve here. So let's go ahead, let's first of all, let's figure out what that even is. We need to get ourselves into polar mode if we're going to graph something in polar, if we're going to graph a polar equation. Alright, let's go ahead and graph. We'll graph r equals 1 plus 2 cosine theta. Alright, let's get a window that makes sense. Theta going from 0 to 2 pi, that's good. Notice that the biggest r could be is 3, so the biggest, the furthest we could be away from the origin is 3. So if I have x and y go from -3 to 3, I'm guaranteed to be able to see the whole thing. Okay, so there's our graph, and so you notice this right here, this is the inner loop that we're talking about. Okay. The tricky thing here is to figure out the limits, right? The limits of theta that just give us that inner loop. And what we have to realize is that the inner loop starts at the origin, traces around like this, and then ends at the origin. So the inner loop starts and ends at the origin. Okay, the origin is where r equals 0. So in other words, where 1 plus 2 cosine theta equals 0. And this is, we want to solve this equation to figure out the exact values of theta where we hit the origin. If you subtract 1 from both sides, you'd get 2 cosine theta equals -1. Divide both sides by 2, that means cosine theta is -1/2. And then if you were to look on your unit circle, the two values where cosine theta is -1/2 would be 2 pi over 3 and also 4 pi over 3. Those are the two solutions between 0 and 2 pi. And just to verify that, let's change our window. Instead of letting theta go all the way from 0 to 2 pi, let's go from 2 pi over 3 to 4 pi over 3. And let's just verify that that range of theta only gives us the inner loop. That's all we want for this problem. And it does. Okay. So that that's the only part of the graph that we want. So we have to only think about the theta values between 2 pi over 3 and 4 pi over 3. All right. Let me go ahead and draw just a little bit bigger here. Right, the inner loop looks like this. Nice and symmetric. The first point, the point where that inner loop starts is theta equals 2 pi over 3. The part, the point where it ends is theta equals 4 pi over 3. As theta increases, it actually gets traced around like this. Notice this point right here, this is actually theta equals pi. All right. Now, normally pi is over here, right? Normally this is theta equals 0 and theta equals pi is over here, like on the negative x-axis. But look what happens if you plug in theta equals pi. Cosine of pi is -1, so this is -2. 1 plus -2 is -1. R is -1 if if theta is pi. So the fact that you have a negative r value, see, normally if r was positive, this point would be over here, but since r is negative, you walk backwards from that direction, and it's actually over here. Okay, that's kind of nice, because what I'm going to do is I'm going to realize that this region here is very symmetric. Okay, of course I want the area of the whole thing. But what I'm going to do to make it a little bit easier on myself is I'm going to realize that the bottom half is the same as the top half. So if I only integrate from 2 pi over 3 to pi, that would give me half of it, right? And even you could verify it on here. If you go from 2 pi over 3 just to pi, that gives you just half of that inner loop. So if I integrate, if I use the area formula and integrate over that region, that'll give me half the area, and then I can just multiply by 2 to get the whole thing. Okay, so the area, it's twice the integral from 2 pi over 3 to pi, and to get polar area, it's 1/2 r squared. Right? Remember, that to get polar area, you integrate 1/2 r squared d theta. Okay. Let's see, the 2 and the 1/2 cancel. That's nice. So you got integral from 2 pi over 3 to pi. You do have to FOIL this out, so it'd be 1 plus 4 cosine theta plus 4 cosine squared theta d theta here. You are going to want to use the half angle formula to rewrite that in order to integrate it. So you got integral from 2 pi over 3 to pi, 1 plus 4 cosine theta plus 4, and then half angle formula says this is a half plus a half cosine of 2 theta. Using that identity makes things, makes it easier to integrate. Okay. We do have to distribute that 4. 4 times a half is 2, plus 1 is 3. So you got a 3, you get a 4 cosine theta, and then 4 times a half, this would be 2 cosine of 2 theta. Okay. Now we have it to a point where we can integrate. Okay, the integral of 3 would be 3 theta. The integral of 4 cosine theta would be 4 sine theta. The integral of 2 cosine 2 theta would be just sine 2 theta. Right, because it'd be a 1/2 that comes out when you integrate because of the 2 theta. That's evaluated from 2 pi over 3 to pi. Okay, if I plug in pi, I'd get 3 pi plus, well, the sine of pi is 0, and the sine of 2 pi is also 0. If you plug in 2 pi over 3, 3 times 2 pi over 3 would be 2 pi. The sine of 2 pi over 3 is actually square root of 3 over 2. The sine of twice 2 pi over 3, so in other words the sine of 4 pi over 3, that's minus square root of 3 over 2. For a grand total of, let's see, you got 3 pi minus 2 pi, that's pi. And then right here, you got 4 square root of 3 over 2 minus square root of 3 over 2, so that, this right here is 3 square root of 3 over 2, and then you are subtracting that, so it's minus 3 square root of 3 over 2. That would be the exact area of this inner loop here.